Welcome to Episode 59, Resource Hierarchy for Access and Control. In large cloud environments, structure is the antidote to chaos. Without clear hierarchy, policies scatter, permissions drift, and accountability blurs. Google Cloud's resource hierarchy provides the scaffolding that keeps operations organized and secure. It defines how resources, such as projects, folders, and organizational nodes, relate to one another and how controls flow between them. A well-structured hierarchy ensures that security, billing, and governance align with the organization's actual structure. Rather than managing individual resources in isolation, teams can define policies once and inherit them predictably downward. Structure makes complexity manageable, transforming what could be a tangle of ad hoc configurations into an orderly, comprehensible system for access and control. At the top of this hierarchy sits the organization node, serving as the root of all resources. It represents the company's Google Cloud identity and acts as the central authority for policy enforcement. From this node, administrators can apply global security constraints, billing settings, and audit configurations that automatically cascade through every folder and project below. The organization node also defines ownership boundaries, ensuring that only authorized administrators can create or modify lower-level resources. For example, enabling Security Command Center visibility or defining data residency controls at this level guarantees consistent protection across the enterprise. Treating the organization node as the single source of truth strengthens governance and prevents shadow environments from bypassing oversight. Folders mirror business units, functional domains, or product lines within the hierarchy, creating logical groupings that reflect how teams actually operate. Each folder can inherit policies from the organization node while also defining its own localized rules. This allows flexibility without losing global consistency. For instance, a company might maintain separate folders for engineering, finance, and marketing, each with distinct permissions, billing budgets, and compliance controls. Folders can also support delegated administration, granting business leaders oversight of their team's projects without affecting others. In practice, this design maps human organization to cloud organization, ensuring that operational and managerial boundaries remain aligned. Projects serve as isolated workspaces where actual workloads, data, and services live. They form the primary unit for access control, billing, and resource organization. Every virtual machine, storage bucket, or function belongs to exactly one project, which simplifies ownership and accountability. Projects make experimentation safe by containing risk. Errors or misconfigurations within one project cannot directly compromise another. For example, a developer testing new code in a sandbox project operates independently from production workloads. Assigning clear project purposes, such as analytics dev or customer app prod, keeps environments comprehensible and manageable. Projects are the building blocks of structure, providing the right balance between isolation and governance. Inheritance and scoping within Identity and Access Management, or IAM, define how permissions propagate through the hierarchy. When a role is granted at the organization or folder level, it automatically applies to all projects beneath unless explicitly overwritten. This inheritance simplifies management, but also demands caution. A broad grant at the wrong level can expose more resources than intended. Scoping permissions appropriately, granting only what is needed at the lowest relevant level, follows the principle of least privilege. For example, giving developers viewer access at the folder level but editor access only within their assigned projects limits potential damage while maintaining efficiency. Understanding how IAM inheritance works ensures that access remains intentional, predictable, and auditable. Service accounts bring automation into the access model while maintaining the same principle of least privilege. These special accounts allow applications and services to interact with Google Cloud resources securely without relying on human credentials. Each service account should have narrowly scoped roles reflecting its function. For example, allowing a backup service to write to storage but not read sensitive data. Keys and tokens must be rotated regularly, and activity should be logged for auditing. Service accounts also benefit from workload identity federation, which maps external identities to Google Cloud permissions without long-lived keys. Managed carefully, service accounts become trusted participants in governance, extending security from human users to automated systems seamlessly. Organization policies add another layer of control, constraining risky capabilities across environments. Administrators can enforce rules such as disallowing public IP addresses, restricting which regions data may reside in, or preventing the disabling of logging. These policies apply uniformly across the hierarchy, reducing the chance of accidental noncompliance. For example, enabling an organization policy that prohibits external sharing of storage buckets prevents exposure across all projects simultaneously. Org policies turn high-level governance principles into enforceable technical rules, translating business intent into configuration reality. They act as guardrails that keep freedom productive while ensuring that every environment remains within approved boundaries. Naming conventions, labels, and standardization create the connective tissue that keeps large environments coherent. Consistent resource names, incorporating project purpose, environment, and owner, make identification intuitive. Labels add searchable metadata, enabling cost allocation, access auditing, and automation. For instance, labeling resources with keys such as team-analytics or env-production allows reports and policies to group them meaningfully. Standards should be documented and enforced through automation, not left to individual discretion. Clear naming and labeling conventions make troubleshooting faster, governance simpler, and reporting more accurate. They convert potential ambiguity into operational clarity. Separating development, testing, staging, and production environments maintain safety and predictability. Each environment deserves its own projects or folders with progressively stricter controls. Developers can experiment freely in isolated sandboxes, while production workloads remain protected under stricter policies. For example, deploying a new application might begin in dev for functionality checks, move to stage for integration testing, and end in prod once verified. This structured separation prevents accidental disruption of live systems and simplifies rollback during failures. It also reinforces compliance, since production environments often carry distinct monitoring, logging, and approval requirements. Environment segregation ensures that innovation and stability coexist without conflict. Network segmentation across environment tiers extends isolation into connectivity. Separate virtual private clouds, or VPCs, can define traffic boundaries between development, staging, and production. Firewalls and routing rules restrict unnecessary communication, ensuring that a compromised environment cannot affect others. For example, a staging network might allow outbound traffic to test APIs but deny inbound access from production systems. Shared services, such as identity or monitoring, can reside in controlled hub networks connected via private peering. Proper segmentation supports zero-trust principles, reducing lateral movement and limiting the potential impact of misconfigurations or intrusions. Well-defined network tiers turn abstract governance policies into concrete, enforceable architecture. Auditability ensures visibility across every boundary of the hierarchy. Logs collected at the organization, folder, and project levels record actions, changes, and access attempts. Centralized storage of these logs enables correlation and analysis, helping identify patterns of misuse or potential misconfiguration. For instance, reviewing admin activity logs at the organization level might reveal unauthorized role grants that individual project logs could miss. Consistent log retention policies and integration with monitoring platforms create a comprehensive audit trail that satisfies both operational and compliance requirements. Auditability is the bridge between trust and verification, proof that governance works as designed and that every action leaves a traceable record. Break glass controls and emergency access procedures provide resilience during crises. When automated systems fail or credentials are lost, organizations need predefined methods for restoring access without compromising security. Break glass accounts are highly privileged but remain locked and monitored until explicitly needed. For example, if an identity provider outage prevents normal logins, a break glass procedure allows restoration of service while preserving full audit visibility. Access through these accounts must be time-bound, approved, and followed by immediate review. Building these safeguards into the hierarchy ensures continuity under exceptional circumstances while maintaining accountability and control. Mergers, divestitures, and restructuring events test the flexibility of any hierarchy. When organizations change shape, Resources and permissions must adapt quickly without jeopardizing compliance or uptime. Google Cloud supports reassigning projects and folders under new parents, allowing seamless realignment. For example, when a business unit spins off, its folder and projects can move to a new organization node while retaining their configurations. Planning playbooks for these scenarios ensures that structural transitions occur smoothly with minimal disruption. Treating hierarchy management as an evolving framework rather than a static design prepares organizations to scale, reorganize, and adapt with confidence. Hierarchy simplifies control management by embedding order into every layer of the cloud. When designed thoughtfully, it aligns technical architecture with business structure, making governance natural rather than burdensome. The organization node defines authority. Folders model ownership. Projects isolate work, and inherited policies tie it all together. Visibility, security, and accountability flow naturally through this structure. Far from adding bureaucracy, hierarchy reduces complexity by replacing improvisation with predictable patterns. In Google Cloud, structure is not a limitation. It is the framework that enables safe growth, consistent policy, and operational clarity across the entire enterprise. Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.